Hello and welcome to another iGCSE and IB chemistry video with Mr. S. Today we're going to be looking at the trends down group 1, the group called the alkali metals. The first trend we're going to look at is melting point. Now the melting point decreases down the group because the metallic bonding gets weaker. Now a quick recap of metallic bonding where the ions of the metal, the cations, the positive ions, are arranged in a lattice in ordered structure, and the electrons are delocalized. In this example, we can say that this ion has a charge of +1, so it's lost one electron, and that electron is free to move throughout the structure. Now, why does it get weaker down the group? As you go down the group, the ionic size gets bigger because you're adding more and more shells of electrons. Now, the bigger the ion size, the weaker the attraction between the nucleus, which is positive in the middle, and the delocalized electrons. So the electrostatic attraction gets weaker. Again, between the nucleus and the delocalized electron. So that is why, for example, lithium will have a higher melting point than sodium, because sodium is lower in the group. Now, the second trend that we do see is that reactivity increases. This is because electrons can be lost more easily down the group. Again, this has to do with the size of the atom. Before it was the size of the ion. I have the two drawings here of lithium and sodium. Sodium has 3 shells occupied, and therefore the outermost shell is far away from the center, the nucleus, and therefore the electrostatic attraction is weaker. So, as we can see, from distance between the nucleus of lithium and the outer shell electron is smaller than the distance between the nucleus of sodium and the outermost electron. So therefore, the electrostatic force of attraction is weaker, and therefore sodium can lose an electron more. Now, what does this have to do with reactivity? Well, metals, when they react, are losing electrons. So from sodium atom to the sodium ion. So the more easily you can lose an electron, the more likely you are to react. Now we see this trend when you react with water. Sodium is more reactive when it reacts with water than lithium. The common reaction that we see in the lab, sodium plus water, alkali metals plus water make the alkali hydroxide, sodium hydroxide, and hydrogen gas. So this reaction here is going to be more vigorous if you put piece of sodium, than a piece of lithium. So that explains the two trends in reactivity. Metallic bonding decreases in strength, therefore the melting points decrease down group 1, and the reactivity of the metals in group 1 increases down the group. Thank you very much for listening. I hope this has helped.